Welcome, class. Today I'm going to let Johnny introduce the lesson.
Today's lesson is scientific notation, and scientific notation is a compact way of writing numbers that are either very large or very small.
Thank you, Johnny. All right, so to start off, we're going to go over the rules for scientific notation. This should be a review for most of you. The first number, remember, has to be greater than or equal to 1. So I always say like between 1 and 10, but it can be 1. It cannot be 10. Anywhere from 1 to 9.9. If the power of 10 is positive, you have to move the decimal point to the right. So when you're putting it in standard form, if the power of 10 is positive, like positive 5, we'll move the decimal point to the right 5 times to put it back into standard form. If the power of 10 is negative, you'll move the decimal point to the left. That means it's going to be a very small number, so a small decimal. And that's putting it into standard form. So let's keep going. So when you're writing numbers in standard form, which you'll have to do on your paper, just follow those rules. If the exponent is positive, like this positive 4, we will move that decimal 1, 2, 3, 4, and any blanks we'll fill in with zeros. So 73200, and go 3 times, put a comma. The 4 does not mean you add 4 zeros. It means how many times you move the decimal. So the 32 takes up 2 of those spots. And looking at the next one, we have a 931 taking up 3 spots, and we have to go 2 more. So we'll just be adding 2 more zeros. And that's 5 times. From here to here is 5 places. And then we'll go back and put a comma, 993,100. All right, let's keep going. Now a negative. This is when we go the other way, and it's only 1, so we just move it 1 time and stop. So the answer is 0.455. And then this one's negative 4, so we're going to go to the left negative 4 times. The number in front of the decimal takes 1 of those spots. Then we'll go 1, 2, 3 more, so we'll be adding 3 zeros in front. So it's a decimal 1, 2, 3, 6, 0, 2. Keep all these numbers in your answer. They stay there. And that's it. Now we're going to review going backwards. So we're going to put each number back into scientific notation. So it's just backwards. If the decimal on any whole number is at the right, you have to move it to where it stops. The number where it stops between has to be between 1 and 10. So I'm going to go all the way to right here and stop between my 2 and 7 to where it's 2.77. Any zeros drop off. Don't write them. But then you'll do times 10, and then your exponent will be how many times you had to move your decimal. And I had to go 5 times. So it's 10 to the 5th power. And it is positive because it's a big number that I'm putting back into scientific notation. So I definitely want it to be a positive. This one, the decimal point starts at the end. I'm going to go 3 times, 6 times, and then 3 more times because I want to stop between my 8 and my 7. That's between 1 and 10. 8.785 is between 1 and 10. I dropped off the rest of my zeros, and then I'm going to say times 10 to the 9th power because I went 9 times. And let's go the other way. Let's put some small numbers into scientific notation. This time I'm going to have to go the other way. I've got to go to the right, and I'll go 1, 2, 3, 4, 5 times. And I'm going to stop right there because when I write that, 4.955 is between 1 and 10. If I went to the end between my 5s, I'd have 495, and that's too big. So you stop right here, times 10 to the, and 1, 2, 3, 4, 5. I forgot how many times we went. It's 5 times, but you have to make it a negative because this was a decimal we put into scientific notation. So it has to show that it's a small number. Okay, same thing here. I need this number between 1 and 10, so I just have to go 1 spot. So it's 5.24 times 10 to the negative 1, because I went back to the right. Going backwards, the rules are backwards. All right, that's the beginning part of your assignment. Just reviewing scientific notation. It's pretty straightforward and easy. Now we're going to go to the other half of your lesson, and this is when we're actually going to multiply with it and divide with scientific notation. In this situation, it also will bring in your monomials, your rules with monomials that we've been studying very recently. All right. You're going to be able to use a calculator on this part. And so I brought it in on the lesson. When you look at multiplying scientific notation, first thing you're going to multiply your front digits together like normal. So we're going to do 6.5 times 8.7. 6.5 times 8.7 gives us 56.55. Times 10 to the, and on the powers of 10, since they are powers with the same base, our rule is to add exponents when we're multiplying. So we'll do 12 plus negative 15. And when we add those, we actually get a negative 3. Now I've combined them. Look at your answer and see, is it in correct scientific notation? And when you look at the front number, it is not, because 56 is greater than 10. So I have to adjust this by moving my decimal back to the left one time to where the answer now is 5.655 times 10. Now, when you are putting a number back into scientific notation and you move it to the left, that's adding 1 to your power of 10. So then when we work out negative 3 plus 1, it's negative 2 now, because I went back to the left. And there's your answer. Let's do the next one. Clear out our calculator. And we'll start with 1.95 times 7.8. And we'll get 15.21 times 10. Now it's negative 8 plus negative 2, which is a negative 10. Same situation. Our 15 is bigger than 10. We're going to have to move the decimal back 1. So it's 1.521 times 10 to the. Now remember, going back to the left when you're putting in scientific notation adds 1, so it's 10 to the negative 9th power. And there, it's finished now. Now that we've put them both into scientific notation, I want you to look back at the instructions you're going to see on your paper. We have to write it in both scientific notation and standard form. So we're going to go and we're going to change this to standard form. The first one, 5.655. We're going to move the decimal back to the left 2 times. So it will go decimal 0.56. Whoops, 55. That looks bad. And that's our other answer. And then this one will go to the 9 times back to the left. That means I'll be adding 8 zeros in front of that one. So decimal 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 5, 2, 1. And there's my other answer with that one. So you're going to do scientific notation and standard form. Let's go to another example. Oops. Make sure we've got this. We'll do 2 more like this. Bring up our calculator again. Clear it out. We're going to do 2.9 times 5.2. We get 15.08 times 10. Negative 2 plus negative 9 makes a negative 11. And then we'll have to move our decimal back 1.508 times 10. And if we added 1 because we moved back to the left, it'll be negative 10. So here's one answer now in scientific notation. And now we're going to go ahead and put it in standard form too. That means I have to move the decimal 10 times to the left, and the 1 takes one of those spots, so I'll be 9 zeros in front. 7, 8, 9, 1, 5, 0, 8. And there's our second answer. Make sure I can see that decimal point. All right. The next one is 7.08 times 5, and you get 35.4 times 10, and then it's 14 plus negative 9. So that makes 10 to the 5th power. And we have to move the decimal back one place. So it's 3.54 times 10. And then since we added 1, or moved it one place to the left, we'll add 1 to the exponent. So it's 10 to the 6th. And there's our standard form answer. Now we'll do our scientific notation answer. Now we'll do standard form. We'll move it back to the right 6 times because it's a positive exponent. So it's 3. The 5 and 4 take 2 of those spots, and then 3, 4, 5, 6. And we'll put a comma here and a comma here, and here's our standard form of that scientific notation. Okay, guys, I have to show you some division, and we'll be finished. So let's go on down to, here's some division problems. Same drill. We will divide our numbers like normal. 2.3958 divided by 1.98 gives us 1.21 times 10. Now, the rule with dividing powers of the same base is we subtract the exponents. So it's 3 minus 8, so it's 10 to the negative 5. And we can stop because our first number is between 1 and 10. So right away, that's already in scientific notation. All we do now is write it in standard form. So negative 5 means I'll go back to the left 5 times. The 1 takes 1 spot, so I'll add 4 zeros. 1, 2, 1. And there's my second answer with that one. Okay, real quick, let's try to get through another one. 1.305 divided by 1.45, and that gives us 0.9. So I've got 0.9 times 10, and then it's 3 minus a negative 4. So it's 3 plus 4, which gives us 7. And this one's interesting because now I've got to move back to the right 1 time to put that between 1 and 10 to make it a whole 9 times 10. Now when we're going to move it back to the right, when we go to the left, we added 1. When we go back to the right, we've got to subtract 1. So that'll be 9 times 10 to the 6th power. And that is in scientific notation. All we do next is write it in standard form. So we'll add, since the decimal is at the end of the 9 at the right here, we'll move it 6 times. Since there's no numbers taking any of those spots, it's just adding 6 zeros this time. 1, 2, 3, 4, 5, 6. Go 3 times and put your commas for your series. And the answer is 9 million. And there it is. Okay, guys. We're kind of up on our time on our video. There's really nothing more than what I've shown you. Just follow your rules with your monomials and dividing and multiplying, and use your calculator to multiply and divide your numbers. And I will see you in class.